5-2 in your digital classroom over here, Google Classroom. I'm going to go to 5-2. Select that. Again, the fact that you're listening to me tells me you have completed number 1 up here. You're attending class. As it stands today, no one's in the classroom. No one's on campus, but I do have 22 of you online right now, and I will post this later to YouTube as well. Okay. Make sure you fill out your attendance link. It's the same as this link right there. They're both one and the same. So you can click it from over here if you'd prefer. And then once you fill that out, open up your lesson exam. So as we go through the lesson today, you can submit your answers. So make sure you get that in. We will possibly, I know we'll use Desmos just to check our answers. So I'm just going to go ahead and open up the Desmos graphs right there. And I'm going to get just a blank one to start off the lesson. Actually, take that back. Instead of doing blank, I'm going to open up number 11. Graph number 11. The right triangle trigonometry. I'm going to have that one open. And that's just because on this graph, once it ever gets open, it'll have our ratios for trig. In case we need those today, I'll have that open on the left side of the screen. There they are, those ratios right there. All right, with that, I'm going to start on our bell ringer. So number 1 says, if cosecant equals 3 and cosine is less than 0, find cosine and tangent. And so by way of reminder, the way we were solving last class, we were using identities, which is basically how you can exchange, like substitute one thing for another. It's kind of one way to think about it. And so cosecant, according to these ratios over here, is equal to h over y. So that's how I'm going to start. I'm going to start by just substituting here h divided by y. Now this number is just a 3, so we can always turn it into a fraction of over 1. Now here's what this does for me. By rule, h is always positive. So no matter what, this has to be a positive 3. h is positive 3. Well, that means y has to also be positive. Now, we learned last time that you could have a negative and a negative, but since h has to be positive and overall cosecant has to be positive, the y also has to be a positive 1. So if you were going to draw a triangle, you would need to make sure you drew yours where the y-axis is going upward, because we know we have a positive y value of 1 unit. So I'll just put an x. We don't know much about the x yet, so I'll just do a normal x-axis. But we do know right off the bat that y is going to have a value of 1. So that's going to be our y. We know h will be 3. Now we come over here. This says cosine is less than 0. Well, cosine is x over h. So I could say x divided by h is less than 0. And honestly, we know h is 3. So if you wanted to, you could just replace that with a 3. So x divided by 3 is going to be less than 0. And just kind of get an idea about x, I could here get rid of the division of 3. What is the opposite of dividing by 3?
Multiply by 3.
That's right. If I multiply both sides by 3, I should have an equivalent equation here. And this is saying x is less than 0 times 3, which is still 0. So x is negative. So what we just determined is if we were going to draw a triangle, we would need to draw it in the second quadrant, meaning it needs to be up 1 unit, which makes a positive in the first 2 quadrants. And then because x is less than 0, it's got to be in the second quadrant on the left side. So we'd have some triangle over here where we don't know the x. So I'm just going to kind of draw diagonal like this. We don't know the x value. That's unknown to us. All we know is it's some negative number, but we do know the h is 3 and we know the y equals 1. We just don't know the x. So how could we solve for the x? With a right triangle, that's what I have here, a right triangle, and I know 2 sides. How could I solve for the third side?
Pythagorean theorem.
Pythagorean theorem, very good. Thank you. So I have x squared plus y squared equals h squared. Thank you, Journey. And when we plug in our numbers, we don't know x, we do know y, and we do know h. So x squared plus 1 times 1 is 1. 3 times 3, or 3 squared, is 9. So we go through this process of solving. I'm trying to get x by itself. I need to isolate, which means do the opposite. So I'm going to subtract 1. So x squared will equal 8. And how do we get rid of a square?
A square root.
Yep. Now normally in math, if you add a square root that's not originally there, you need to add a plus or minus. On this problem, we don't need to add a plus or minus though, because we know that x has to be negative. So I'm just going to put a minus symbol there. X is going to be the negative of the square root of 8, which is the same thing as the square root of 4 times the square root of 2. What I'm doing is I'm breaking the square root down. Since 8 is not prime, it can be reduced, so I'm breaking it down to square root of 4 times square root of 2. And the reason I did this is because we know the square root of 4. What is the square root of 4?
2.
So it's negative 2 times the square root of 2. That's our x value. So I'll come over here and replace that. X equals negative 2 square root 2. And now we can find cosine and tangent. Cosine is x over h. So it'd be negative square root of 2 over 3. Oops, negative square root of 2 divided by 3. And then tangent will be y over x. I'll let you do that one. What I'm going to show you there real quick is I will show you how you could try this on your own, like using the calculator to solve. Not that this is perfectly guaranteed to work, as it won't give you the positive or negative. At least I don't know how to make it do that. But here's what I could say. If I were going to use the calculator to check this, I would need to solve for theta. And so I'll do it this way. I'll say, the way you do that, by the way, is you do an inverse to swap the two. So theta here, let me shrink this a little bit. Theta, I just typed in T-H-E-T-A, and it changed that. The computer went slow there. Let me type it in again. Theta, there we go. As soon as I hit that A, it changes to a theta. Theta would equal CSC inverse. So an inverse swaps, if you remember that, of 3. Okay, now that's not storing for some reason. That's unfortunate. There we go. If I put theta 1, it works. So it stores the value, and right now it has me in degree mode. So if you're in radian mode, you'll get a different answer. But for this, it doesn't matter. I'll leave it in radians, actually. So there's our value for theta 1. And it says theta 1's got to be less than 0. So, sorry, let me try this. Cosine of theta 1 needs to be less than 0, which means I need to take the negative of this over here. I need to take the negative. So now if I did that, nope, still not working. I'll play around with this in a second. I might not know how to do this totally on Desmos. Either way, I got what theta 1 is. We're supposed to find cosine. It's giving me this number. I'm going to try it without using the negative. 2 square root 2 divided by 3. Okay, there we go. You can see these match up. I know I took away the negative, but that's because the cosine was supposed to be negative. If I put a negative there, and put a negative there, you can see that they match up. So I just used inverse there to solve for theta, and I plugged it in. And so the tangent, if you type that in, let's see here, tangent theta 1. Again, it's going to give the positive, which it should be the negative because of that x value. Whatever your answer was, it should represent this value. So I saw a question in the chat that says, how do you type theta in again? Let me do it as a quote. You type it in T-H-E-T-A, like the ta. The ta. That's how you spell it. What you do is one word, and if you do that without the quotes like I just did there, it'll immediately change. You say T-H-E, the T-A, the ta. It'll change for you like that. Okay, so that's a way of checking. We did get this answer right. Tangent is y over x, so I'll let you do the y over the x. Actually, no, I'll do it because we have to reduce it. That'll be good practice. Let's see here. Y over the x. We do not leave a square root in the denominator, so I'm going to shoot that up, which means I now have 1 square root of 2. I'll put the 1 there. over negative 2 times 2. So this square root goes away, and so you multiply those 2's, which means we would end up with the square root of 2 over negative 4. That's the answer I'm getting. Let's check that out and see if it matches this number. Square root of 2 divided by negative 4. And yes, they're matching up perfectly. So we did our work correctly. So over here is just a way of checking your answers. All right, I'm going to delete all this. If you didn't catch that, just go back and rewind the video. Let's try number 2. Number 2 is where we start doing this simplifying. Now, as I told you last class, chapter 5 is basically what's so weird about it is we are simplifying rather than solving. So number 1, I did give you a problem to solve. But number 2, we're just told to simplify. And that's tricky for some students because simplifying doesn't just follow set ground rules. So for example, if I said simplify this, well, there's no like set rules. It's not like, well, I need to subtract because it says plus. No, you don't do opposites. When you're simplifying, you just have to look at it, and I don't know how else to say it other than follow the mathematical foundation you have of trying to discover what should I do. And in this case, what I just came up with is you need to get a common denominator. That would be the rule here. You multiply by 7 over 7. And then all of a sudden you could simplify this problem and get 37 over 7 as your solution there, the simplified form. Now, our problem just says simplify and it gives you all this. And many students are like, where do I start? I don't know step 1. And so last class I gave you an acronym. It said SPOT oil, where each letter, except for oil, represents a specific task to check. So the first thing you should try is to simplify. So the first thing we try to do is simplify, and that can be done 2 ways, either by canceling, which I oftentimes write as algebra, but here I'll just write cancel, or you factor, GCF specifically. Okay, so I want you to look on this one. Can I simplify this by either canceling something or by factoring? Is something shared?
X.
By the way, I'm right here, spot oil. Let's simplify, we're going to use spot oil. Okay, yes, X is shared, but that's shared within the function, so I can't actually factor out the X. That's a good idea, but keep looking. There is something that's shared in both the terms. So terms just means things that I add or subtract. Something in this term and something in this term are shared. What is shared in both of these?
CSC.
That's right. So what I'm going to do is I'm going to take the CSC here and the CSC and divide them out. So GCF factoring, greatest common factoring, works kind of like the opposite of distributing. So where like CSC has been distributed here, I'm going to divide it out. And so if I divide CSC by this CSC, I'm left with 1. Then comes the minus sign. And then over here, if I divide all this by CSC, I'm just left with cosine squared. And so that first step right there was greatest common factor. Greatest common factor. That's what I just did there. I'm going to write out my steps as we go, which Alex would call algebra. Alex would just call that algebra if you had to label it on homework. Okay, that was step 1. So this up here is equal to this right there. So all I did is I factored out CSC. So now I come over here and I say, okay, can I now cancel something or factor something? Answer is no. So the second thing I try is what we call the Pythagorean identity. Pythagorean, I'm just going to write Pythag identity. And on this one, you're looking for ones or squares. Ones and squares. Well, I'm running out of room. We got 1 and squares. Just going to do that simple. Okay, do you have a 1 and a square together now? I do right here.
No, we have a 1 and a square.
Perfect. So I have a 1 and a square. That's what I need. This is going to be the Pythagorean identity right here. So this next step, what I will have is CSCX, and then inside this parentheses we will substitute with whatever its Pythagorean identity is. And so where do I get those? Well, I showed you how to formulate them last class, but I'm just going to open up the formula chart here. And to make it easier to find, let me copy this, and I'm going to paste it. Oh man, it's going so slow. Here we go. I'm going to paste it right there in between your lesson exam and homework, because that's where you're probably going to need it. So let's click that formula chart open. And I'm going to go to the Pythagorean Identities, and I'm going to look for the one that has a cosine squared. So let me blow this up a little bit. So here's Pythagorean Identity. I see it on the left side of the screen. Pythagorean Identity right there. Whoops. And what I want to do is look for the one that has cosine in it, which is the first one. Now notice this is 1 minus cosine squared. So the algebra to get 1 minus cosine squared means you had to subtract cosine squared. So to get 1 minus cosine squared from 1, I have to subtract cosine squared. So on this, if I subtract on the right, I need to also subtract on the left. If I subtract the cosine squared from the left, all I'm left with is sine squared. So over here, 1 minus sine squared is equal to, 1 minus cosine squared is equal to sine squared. That right there is the Pythagorean identity. Now all that is some algebra, what I did on the formula chart. Okay, and that is the name on Alex. It's the same name as what I just wrote. What I did is basically, let me change colors here. We have sine squared, on the formula chart it says sine squared theta plus cosine squared theta equals 1. And what I've done is I came in here and I took this, I'm going to leave this as red so I can swap it, and then I'll go purple, cosine squared theta. Okay, so if you want to get rid of an adding of cosine, you must subtract it. So when I subtract it on both sides, I'm left with negative cosine over there, and now just a sine squared plus nothing. So just a sine squared on the left side. Whoops, why didn't that go together? Sine squared theta. Theta just doesn't want to move. It's comfortable. Well, that's strange. Either way, I'll just leave it with the gap. And so that's what I did to get that identity right there. Okay, so now I'm back over here. So, and I'll label these steps. That's the first thing I did. This was the second thing I did. Now we go back and say, okay, can I simplify this? Answer is I can't cancel, nor can I factor. They're not the same. I can't cancel. Okay, can I do Pythagorean identity? I see a squared, but no, can't do Pythagorean identity. I just did that. So number 3 would be opposite denominator. That's the conjugate. I call it opposite denominator, but we're not going to do that one because I have no denominator. So I'll skip the opposite denominator step. And now I'm going to go to transform. This one is transform. I'm going to transform things to sines and cosines. Transform to sine or cosine. And so I see CSC is not in sine cosine form. So what is CSC equivalent to? So I look right here, right above. This is called a reciprocal identity. And I find out that CSC, whoops, keeps swinging on me. There we go. CSC is equivalent to 1 over sine. So CSC becomes 1 over sine x. And then I'm going to leave this as it was. I'll just put it in blue here so you can see that nothing changed from that step. So right there, I just did the third step. I transformed a sine and cosine, which this I transformed. Let me put transform here. The Alex name for this is the reciprocal identity. Okay, and now finally I come back and I say, okay, I go back to the start. Can I simplify? Can I cancel anything here? And the answer is yes. So I'm going to do a 4 here because it's going to be the fourth step. We can cancel I can cancel one of those signs that's dividing with one of these signs that are multiplying. There's two multiplying, one dividing, so that cancels that one. And I'm left with sine x as my solution. So this was step 4. I simplified by canceling. And again, the name that Alex uses for this is algebra. And so all of this right here, that's CSCx minus CSCx cosine squared x is equal to sine x. That's our solution there. We have totally simplified it. So let's check it. I told you earlier, open up a Desmos so we could check our work. And so that's what I'm going to type in here. I'm going to see if these two are congruent when I graph them. So I'll type in CSCx minus CSCx. Now here's the deal in Desmos. So you need to put a multiplication if you have back-to-back trig functions. Cosine squared x. Okay, and I think it also helps is if you put parentheses around the letters. There we go. Now it's graphing. Okay, so now there's the graph, and I want to see, is that the same thing as sine x? And you can see the graphs are identical, so we did solve it correctly.